Series and parallel circuits are one of the most common questions to pop up when you study physics. So what are they really? In this video, we will go over the applications, numerical properties, and some practice questions. Starting with the simpler one, series circuits are circuits with just one path for the electricity to travel through, as per example here. The total voltage and resistance in a series circuit add up, while the current remains the same throughout the circuit. This means that if you want more voltage, you can just add more batteries. Series circuits use less wires compared to parallel circuits, making them easier to learn and less likely to overheat. However, if one of the components fails, then everything fails. And if we add more load, for example light bulbs, you increase the total resistance since it adds up. Common places to see series circuits include Christmas lights and a simple desk lamp with an on-off switch. Moving on to parallel circuits now. They are circuits with multiple paths for the electricity to travel through, as per example here. In the case of parallel circuits, the total current adds up, while the total voltage stays the same. The resistance also adds up, but as reciprocals like so. The nice thing about parallel circuits is that if one component fails, then the entire circuit can still function, and that the voltage will be fixed throughout the entire circuit. However, this also means that if you add more batteries, only the current is increased but not the voltage. If you have different voltages of batteries in parallel, the total voltage will just fall somewhere in the middle. Parallel circuits also are more complex and take a lot more wiring than series. We use them in our homes to power different appliances, as you can just plug in and unplug your phone anytime without stopping the power to your entire house. Lastly, let's touch on Ohm's law, which states V equals to IR, or voltage equals to current times resistance. You will use this a lot when it comes to circuit questions, along with the properties of voltage, current, and resistance in series and parallel circuits. Now let's do some examples. What are the missing numbers here? Pause the video to try to figure out first. We know that the total resistance is 5 ohms, and so using V equals IR, we see that the current is 2 amps. And using this information, we can calculate the voltage at the light bulb as 4 volts and at the resistor as 6 volts. Next, let's try this parallel circuit and find the total resistance and current through each of the resistors. The currents are easy. We just use V equals to IR to get 12 volts, 6 volts, and 4 volts. To find the total resistance, we just add the reciprocal of each resistor, so 1 over 1 plus 1 over 2 plus 1 over 3, which is 11 over 6. We then need to flip it over to get 6 over 11, as that's the reciprocal in our total resistance. So now, how about a series parallel circuit? What are the missing numbers here? We want to treat the resistors in parallel as a single resistor. Using the parallel resistance formula, we see that the parallel resistors have a combined resistance of 4 ohms, which means that the total resistance of the entire circuit is 10 ohms. And using V equals to IR, the total current is 2 amps. So at the light bulb, the current is still 2 amps as it is in series, so its voltage must be 12 volts. At the two resistors, they must have a combined current of 2 amps as well, so their combined voltage must be 8 volts, meaning that at each resistor, the current is 1 amp. And there we have it. Series circuits have one path, and their voltage and resistance adds up, while their current stays the same. Parallel circuits have multiple paths, and their current adds up, while their resistance adds up using this reciprocal formula, though their voltage stays the same. And remember, Ohm's law solves everything. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything.